Okay, hi everybody. This is Tom James. I am talking to you from Grand Rapids, Michigan. I hope everyone has had a good session or conference so far virtually. Strange times we're living in. So if you are hoping to be at the session on soils, you are in the right place. And I'm happy to be moderating this session. It's formally called, what is it called? Potential Uses of Soil Quality Information to Inform Major Issues in Development Economics. And this is a session that Bill Burke and I dreamed up, I don't know, 8 months ago now. Based on work that the two of us have been involved in over the last few years. I think that one of the first people to really work on this topic and show how soils really interacts with many farmer behavior decisions was Pascual Morenya and Chris Barrett back in their AJAE article, I think from 2009, showing how soil quality interacted very much with the decision fertilizer and the response rates of crops to fertilizer. And over the last decade, there's been a lot more work that many other people have done on this topic. We're aware that, so we tried to assemble a team of people who we knew were also doing work on this, and happy to introduce them now. So the first one is Leah Beavis from Ohio State University. Leah, thanks for joining. Bill,
glad to be here.
Okay, good. Bill Burke, who's affiliated with Michigan State University. Bill, welcome.
Thanks, Tom.
And the third panelist today will be Hope Michelson from the University of Illinois. Welcome, Hope.
Hello.
And we are all more or less on the same time zone, but our fourth speaker is really doing yeoman's duty. It must be something like 10:30 p.m. for him. Thanks for joining us, Takashi.
Hi, Tom.
Hey, thank you for staying up.
It's okay. Yeah, thank you. Thank you.
Takashi is from the Asian Development Bank, but Takashi did a lot of work on soil issues and farmer behavior back a few years ago when he was affiliated with the GRIPS group in Tokyo with Kei Otsuka doing work in East Africa. So we wanted to tap on his knowledge from for this session as well. So here's how I hope we can organize this. So we'll give 10-15 minutes, maybe 15 minutes max to the four panelists. And what we're hoping is that they'll kind of lay out some issues about measurement, data quality, the interaction between household survey data and soil data, maybe some key findings that would be of interest to a broader group. And then, so that'll take us for the first hour for the four panelists. And then there may be some questions or clarifications, which I, as moderator, may ask some questions of the panelists, just to clarify a few things. And then we'd like to open up to the floor. And right now, the floor is maybe about 6 people right now. So hopefully it'll grow over time. But once again, you're all most welcome to this session, and we'll look forward to an interesting discussion. So
we lack in quantity, Tom. We make up for with quality.
Yes, that's very true. Welcome to all of the participants and the audience right now. So with no further ado, Leah, let's turn it over to you, and we'll just go according to the way it was listed in the session. So Leah, then Bill, then Hope, then Takashi. Okay, the floor is yours, Leah. You can share your screen if you'd like.
All right, let me do so. Sorry, I have too many screens open. So when I go to share a screen, it's always a trivial correct screen. I think this is going to be it.
Yep, it's working.
Okay, perfect. Okay. So my name is Leah. I'm an agricultural economist at Ohio State University in the Department of Agricultural, Environmental, and Development Economics. And I'm excited to talk about this. Partly this is sort of, I'm going to piece together some thoughts that I have that are coming from like a number of projects and data work and experience, some published and not published. So I'm really super open to people responding, disagreeing, asking questions about that, because some of them I have sort of thought about a lot, but I haven't talked about that much. A lot of my work with soil fertility data is looking at trace micronutrient deficiencies in soils and how that relates to both low crop yields, but also low nutrient concentration in foods and human micronutrient deficiencies. So looking at, for instance, selenium and zinc deficiency in soils in Malawi and human selenium and zinc deficiency, or soil zinc deficiency in India or Nepal, and human zinc deficiency. So I'm not going to talk about that very much here, but that's sort of one of the main things that I do with soil data. So I'm going to address 3 questions that are really about reconciling measured soil fertility with farmer beliefs or farmer behavior, or our econometric estimates of farmer beliefs or farmer behavior. So the first thing is I'm going to talk about sort of why farmer perceptions of soil fertility as we gather in survey data might not be related to measured soil fertility, and whether that's a good or a bad thing, whether they are meaningful or whether they could even be more meaningful than the measured soil fertility. Secondly, measuring soil degradation, the problem of gathering panel data for soil fertility. And then third, looking at farmer response to gridded geospatial data, where that gridded geospatial data obviously is measured with error respective to the true soil quality that farmers would experience on the ground. So this one I think has sort of been widely discussed, but I have 3 points I want to make on it. So it's widely found, and there's a lot of papers by economists, but also by others, that farmer reported soil fertility aligns fairly poorly with measured soil fertility. That's not always the case, but in large surveys, as a sort of small things run by anthropologists, this tends to be the case. And I think it's interesting to think, like, is this a lack of knowledge on the farmer's part? Is this a lack of miscommunication? Is it a difference in the aspects that farmers are thinking about versus the types of things that we can pick up in measured soil data? And importantly, like, what do farmers believe? Because if that thing that they're reporting is not what we're measuring, but they actually believe it and act on it, then that could be really important, even though we sort of might quote unquote think it's wrong. So the first point I want to make on that is that I think it's important to think about the sort of framing for how farmers are going to report soil fertility. It's often been true that semi-objective reports of soil fertility, for instance, soil texture or color, align better with measured soil fertility than things like my soil is good or my soil is bad, which don't align as well. So Berezhneva et al., Julia's in the audience here, found this in a World Development paper in 2018, and some other papers have found the same. And I think part of the problem might be that when you sort of say something objective, like it's a reddish or a brownish, like that is, you know, fairly objective, whereas the subjective things are going to relate to the framing. And if you're correlating something across a country, like the farmer might not be saying my soil is good compared to somebody in northern Uganda or western Kenya. They might be saying my soil is good compared to my neighbor's soil, or compared to the village over, or compared to my other plot. And I played around with this at some point, sort of doing different framings, and I found that if you demeaned at the sub-county level, which I think perceptibly is sort of the type of frame that a farmer might have in their mind thinking about sort of good and bad soil, then you found a much stronger relationship between what farmers said their soil fertility was and how it related to measured soil fertility. And that made sense to me, but I don't know if that holds more generally. The second point is that there may be shocks to how they perceive their soil. So related to work that I'm doing with Cabroma Bay and Chris Barrett, who also showed up here, I've found sort of that it looks like farmer perceptions of land size may move with weather or yield shocks. And I've also found early evidence, and I know Chris and Paswell Morenia and a couple others that I've talked with have found evidence that soil perceptions also change with shocks. In fact, in this paper by Beresneva and Julia in Rural Development, they also found that yields were correlated with soil perceptions. And a few of us thought about doing something on this and never did. But I do think it's worth thinking about whether farmers are sort of learning about their soils in a way such that if you have a really good year, you think your soils might be better. If you have a really bad year, you think your soils might be worse. And then the third point is that heterogeneity in true soil fertility is so great that I wonder to some extent if that measures a lot of our soil fertility measures that are sort of averaging across a field or certainly across a farm rather meaningless. So soil fertility is known to be very heterogeneous, both within farms and across plots. Famously, Titanal and some others around the same time found that there were gradients of soil fertility within plots moving away from the house or within farms moving away from the house. Lobel et al. Working with the LSMS ISA crew in a paper I think called Eyes to the Sky, Boots to the Ground, to find that they can use satellite imagery to predict crop yields, but only for the plots that are less heterogeneous. There's some plots, in fact, the majority of plots had so much heterogeneity within the plot that it was very hard to predict the yields with satellite data. And in fact, they tossed those plots out when they did that satellite to yield relationship. And maybe that related to underlying soil fertility. So I think the thing to sort of think about here is that each of these have kind of different perceptions for like what we trust, what farmers know, what they don't know. The first point is that farmers might know their soils as long as you stick to the realm that they know about. The second is that farmers may have trouble learning about soil fertility in a chaotic yield where there's a lot of randomness to yields and outputs. And the third is that farmers may in fact have knowledge that we ourselves cannot measure, things about gradients, things about sort of types of soil fertility that vary across space that may be very hard to measure with any sort of quantitative soil measurement. So the second point I want to make is quite mundane and brief, but I think it's important. Development ag economists often speculate about farmer response to soil degradation or about policies that create soil degradation, behaviors that create soil degradation. And when soil scientists discuss soil degradation, when they talk about that, they often base their measures of soil degradation on calculated nutrient flow. So how many nutrients is going into the soil, how many nutrients is coming out of the soil, and they figure that the sort of, if it's positive, then the soil will be improving over time. If it's negative, the soil will be degrading over time. But if inputs or crops are missed, then of course these calculations are going to be wrong. And I think that that's happened very often, sort of in looking at sort of the estimates for some African countries. It seems like it's really strong estimates of soil degradation that don't seem to be showing up in measured data. And I suspect scientists calculating nutrient flow might just miss some of that. And panel data on soils are quite rare. So two examples provide a kind of cautionary tale. One is this example that I worked with in 2013, following up on 2003 data in Uganda, working under Clark Gray at UNC and Ephraim Konya at IFPRI. Also, Chris Barrett was a PI on that. I was a PhD student under Chris at the time, and some other people. And there's another repeat data, it's called repeat in Uganda, that's almost identical timing. It's really curious. And they also have a panel from 2003 to 2012. And when we look at the way that soil metrics are changing over time, it became clear that there might be some problems with the changes in analysis methods that were used between 2003 and 2013. So if you look at this, organic carbon looks like it's going up over time. That would be kind of surprising, possible, but like kind of surprising. Total N looks like it's also going up over time. More dramatically, you do expect N and organic carbon to be highly related, so they should both be going up, and they are. But the increase in total N is kind of dramatic. So maybe that's real, maybe that's not. And then the pH spectrum, right? Like that just looks like there was a different method. And in fact, we looked back and we realized there was a slightly different buffer that was used in the water-based solution that was used to measure pH between 2003 and 2013. Total P and total K look like they're going down over time. Or total P and extractable K would make sense. We would expect that probably to be true, and those look kind of relatively similar in a way that we would expect to move together. So when we dug into the analysis methods, we found two tests, pH and I forget the other one. I think it was actually organic carbon, that looked like there was slight changes in the protocol, not even massive, but things to do with like the water-based buffer that was used for tests that changed over time, which rendered certain types of measures incomparable. And with this repeat soil data, there's a paper coming out in Ecological Economics using that, and I've spoken with the authors about that, and they found the same problem. They also had a particular tests, some that were the same over time, some that were not, and that's a real problem. Like, you would almost rather do the test in a way that is not optimal, but do it again in the same way, than change it over time in a way that you then can't interpret the difference. And very small changes will really change the interpretation. So the last point that I want to make is sort of obvious, but I think hasn't been thought about enough, which is that estimates using gridded soil data, are measured with error, right? So of course we don't always have really good wet analysis soil data, and so we often are using gridded soil data. For instance, AFSIS in Africa, or I'm working with really good soil data, gridded soil data in Nepal. If this measurement error was random, farmer response to soil fertility would be biased downwards, but it's not random. In fact, it looks like this gridded data regresses to the mean pretty much all the time. And there's two reasons for that. One is that each grid cell is a mean. So of course, within a grid cell, it's going to underpredict highs and overpredict lows. And also any regression-based algorithms, such as the random forest algorithms usually used for soil maps, does the same across space. So within an area and across space, you're gonna get this regression to the mean where high soil values are gonna be undercounted and low soil values are gonna be overcounted. This is actually true for non-regression based algorithms as well, such as climate models, but I'll leave that to the side for now. So what we'd like to be doing is looking at some Y that farmers are doing in response to S, the true soil fertility, say soil carbon or soil zinc. What we're actually doing is looking at Y as relates to S instead of S star, which is the gridded data. And then there's this measurement error, the difference between S and S star, the difference between the gridded data at location I and the true thing if we could know it. And then that's going to depend on true data. And it turns out that this leads to a complex biasing term in beta. This is sort of work that I've done for a little bit and is on the shelf, and I haven't finished up in any sort of a published form. But the magnitude, importantly, the magnitude and the sign of the bias will depend on alpha, the relationship between measurement error and the true underlying soil fertility, and on the relative variation between true soil fertility and the random measurement error, not the systematic measurement error. In a recent paper that I have under review at the moment, I estimated that my parameter on soil zinc deficiency was overestimated by 2.9 percentage points. So an estimate of 0.114 as a response on soil zinc would actually reflect an underlying parameter that was smaller, 1.085. Though again, I want to estimate this was sort of specific to the exact form of measurement error that I found in this paper, but the magnitude or the sign could be really different depending on the functional form of the measurement error. So I think that's really important, and we haven't thought about that much when we use gridded soil data. Those are all my thoughts. Thanks.
You're muted.
Oh dear.
Eccoci. Ah, non vai fuori? Troppo
No,
caldo.
caldo, di dove vado? Dove mi mangiano zanzare?
Could we ask everybody to
No, no.
mute their microphones if
Ma
they're not
quando tu
speaking?
hai qualcosa da fare, tu vai?
Se vuoi andare di là,
No, è stato con lei. Un po' visto, cucina e adesso cambiare.
qua va, hai dormito?
Hello, Mario. Would you mind muting, please? Thank you. Okay. All right, Bill, thanks.
Sorry, Tom, were you handing it over to me?
Yes, the floor is yours.
Okay. Hi, everyone. Thank you. And thanks, Leah, for getting us started. Let me share my screen. So I am going to not really talk about any results that I have, although we could, but I'm going to mostly focus on kind of what I've learned about how soil is measured and how soil quality is measured, and then how I've used that in econometric regressions, and kind of touching on some of the same topics that Leah just mentioned. But in the sake of speed, I'm just going to get started. So I think a lot of the people here already have thought about these things, but in case you haven't, if you're like me coming into this, how do you even measure soil? How do you quantify soil is something that I kind of had to learn as we went. And so I think you can kind of break it down into there are two things you can measure when you take soil from a field, right? You can look at the nutrients that are present and the general characteristics of the soil, or both. And when we talk about nutrients that are present, there's basically 17 different nutrients that matter when it comes to how much plants grow and what they produce. We break those down into macronutrients and micronutrients. We talked a little bit already about micronutrients. The macronutrients are what you typically see, but not exclusively in fertilizers: nitrogen, phosphorus, potassium. And then the general characteristics are then the physical, biological, or chemical properties of soil. So there's sort of subcategories of the general characteristics as well. Physics are things like the actual size of particles that are in the soil, so the texture, the clay percent, sand percent, etc. Biology is kind of more along the lines of what Chris and Paz Marina introduced us to back in 2009. Introduced us as agronomists, at least for me. I imagine that agronomists were quite familiar with these topics before them, but so soil biology would be things like soil organic carbon, organic matter. And then another thing that Tom and I and Sig Snap have been working with lately that I'll talk more about is permanganate oxidizable carbon, or labile carbon, POC. And then the chemical properties, things like pH, cation exchange capacity, and so on. So some of the things that I've kind of learned, right, is how to compare these things, or which of these things are feasibly measurable, and then which things, or how they're used in regression analysis, at least for me, right? So what I have come to believe is that measuring nutrients themselves, measuring what's present in the soil in terms of nutrients, is maybe not the best way to go, depending on what you're trying to do. And I should preface everything I'm about to say with the main objective of the work that I've done has largely been to look at the effectiveness of fertilizers on different soil regimes. So depending, looking at some of the things that Leah was just talking about, like how soil affects the health of the people who eat off of that soil might be a different story. But anyway, so some of the things I've learned is that measuring nutrients themselves is not particularly easy to do on a large scale for a couple of reasons. And I'll focus on first nitrogen. One of the reasons it's really hard to measure nitrogen in a meaningful way from soil samples is that nitrogen first of all, it's one of the nutrients that plants require the most of. It's most often the limiting nutrient in agricultural production in a lot of the African countries where I work. But it's a very mobile element. It doesn't stay put in the soil for very long. It can leach down into the soil. It can evaporate as gas. It can be taken up by plants. It can be taken up by weeds. And when plants need the nitrogen is very specific to certain growth stages. So you need to, if you want to collect a meaningful nitrogen reading from the soil, you have to be at the soil. You have to be collecting the soil at the right time with respect to when the plant was planted and when it's growing, or what stage it's growing. Another thing that's kind of something to keep in mind when you're measuring whether or not nutrients are present, which is when you're taking soil samples, that's what you're looking for, right? Is that being present is necessary but not sufficient for being available for plants. So this is where something like phosphorus would be a good example. You can have quote unquote enough phosphorus in the soil, but depending on the physical, biological, chemical properties of that soil, the phosphorus may be bonded to other things in the soil in such a way that makes those bonds stronger and less likely to break when enzymes are released by the plant's roots, and therefore not as readily taken up by the plant. So present and available are not always the same thing, and available is what really matters. And so that's why when you want to know whether or not plants are getting enough nutrients, it's probably better to measure the plant tissue itself. And so how we do this for nitrogen, for example, you can just look at, we have SPAD meters. I think SPAD's the name brand, but you can measure the greenness of the leaves that are in the field at a certain time, depending on relative to the growth stage of the plant. And if the leaves are greener, then that's an indication that there is nitrogen both present and available to plants. And how do you know it's available? Because it actually has already made it into the plant. And then there are more sort of sophisticated or lab-based ways of looking at what other nutrients have made it into the soil. This is more realistic, I've found, both in my own experience and talking to agronomists who've worked on it in smaller samples, rather than, if we're trying to do this on large scales where we're interviewing or collecting samples from thousands of fields across an entire country, being everywhere at the right time is a major coordination challenge, if not entirely infeasible. And the other thing is, from an econometric perspective, whether or not nutrients themselves are present is extremely endogenous, right? So we can augment soil in terms of the nutrients that are there fairly easily. I mean, that's the whole point of fertilizers. So from an analytical perspective, that gives us something that we need to consider when we're talking about nutrient presence. So general characteristics, something like soil physics, one of the benefits of this in comparison is that it's relatively easy to measure in the field. Fairly reliably, well-trained people can do this just using a few hand techniques where, you wet the soil, how does it clump, how does it form ribbons when you squeeze it, and so forth. And again, so you can get like a decent understanding of the relative portions of particle sizes that are within the soil without even using a lab. Kind of some drawbacks here is that soil physics, soil texture is correlated with things like whether or not nutrients are present, and it's correlated with the biological and chemical properties of soil. I don't know if you guys can hear that, but I have a very angry cat who wants to be let in this room. But it's correlated with these things, but it's not a determinant itself of whether or not there are nutrients present or nutrients available, right? And so there's noise in the, well, it's not, even if there's not noise in the data, their explanatory power of soil physics as compared to whether or not, if you were able to quantify the available nutrients that are present in the soil, or as you quantify these other things, bio and chemical properties, there's much less noise in the relationship between those things and the actual productivity of the plant. On an analytical perspective for econometrics, is one thing to keep in mind about soil physics is that unless you're really trying hard to change it and dramatically augmenting soil, this is something that on any time scale that matters to us as human beings is considered a time constant, and so largely exogenous to what we do. Soil biology, I'm going to kind of try and speed it up a little bit, but things that to keep in mind about biology and chemistry, these things can be reliably measured in labs, and with new technologies, that increasingly more reliably measured in fields. I won't dwell on that too much, but these are correlated again with whether or not nutrients are present, right? So this is something that Barrett and Moreña's paper talked a lot about, why soil organic carbon is a good indication of whether or not there are nutrients in the soil and whether or not those nutrients are available. And these are, especially in terms of chemistry, if the nutrients are present, the chemistry is oftentimes what determines whether or not they're available. And then in terms of comparing it to whether or not it's time constant or very endogenous, it kind of depends on which thing you're measuring, right? So, and it depends on the activity of the farmer, obviously. So something like pH can be changed fairly dramatically with the introduction of lime or organic material, large amounts of organic material. But if the farmer isn't doing anything to augment their field, this is a relatively time constant, again, over human time scales. Whereas something like soil organic carbon, Cheryl Palm will be one to tell you that this is something that farmers can really struggle to change over time. But soil organic carbon is something that measures total carbon, whereas one of the things that Tom Sig and I have been working with, permanganate oxidizable carbon, it only measures the so-called labile fractions of carbon. And so this will, in a nutshell, is a way to pick up on how farmer behavior is affecting soil carbon in a way that might get sort of lost in the bigger picture thing if you're looking at only total carbon. So that's kind of my quick summary of how we quantify what soil quality is. How I use it, or how we've used it in econometric analysis, is primarily looking at the relationship between fertilizer and yield. We use threshold models that are based off of the work of Morania and Barrett, 2009, Matsumoto and Yamano. 2013 did very similar work in Uganda and Kenya. Why thresholds at all? And I'll talk a little bit about what we mean by thresholds in a minute if it's not already obvious, but two reasons. One is there's agronomic evidence that there is threshold effects in natural settings, right? So above and below certain critical points, you've got a structurally different relationship between, again, in my case, fertilizer and yield. But also another sort of benefit of this is that threshold estimates are less vulnerable to measurement error in soil quality, which is something that we do worry about for a number of reasons. So ultimately, we're breaking this down to whether or not the soil is a high or low, say, carbon, or high, middle, low pH, and something like that. And so, if you've got a little bit of measurement error, then that is going to affect that categorization of the soil a lot less than if we had to treat it as a continuous variable. This is I'm going to be talking about models that we've published in a number of papers, either out or coming out. This is one that I'm going to highlight specifically because along with this paper, sorry, in case my arrow's not showing up, this is a forthcoming article in Ag Economics. But along with this paper, we've published some Stata commands and do files on how to execute this. So what do I mean by threshold analysis or threshold effects? We set it up so that, or we consider the possibility of two types of threshold effects. The first, type 1, is where the threshold affects how some shift variable, which in this case will be fertilizer, variable that whose effect shifts depending on the regime that it's in, is determined by, so only that shift variable's effect is determined by the soil regime. And that regime is, basically breaks down to a dummy variable, which is 0 if T1, the soil characteristic, is below a critical threshold, and the dummy variable equals 1 if T1 is above a critical threshold. So once you have that established, you just specify a model with an interaction term. And, if you're on the low T1 regime, then the effect is beta 1. If you're on the high T1 regime, the effect is beta 1 plus beta 3 in this stylized example, but it can, you can be more elaborate than that. An alternative, and this is more closely aligned to the Morania Barrett and Matsumoto Yamano paper, is what we have called type 2 threshold effects, where this shifts the entire production function. So now the whole relationship is different depending on whether or not the soil characteristic, called T2 here, is above or below a critical threshold. And in these, again, stylized example, we're using one threshold, but there's no reason, at least conceptually, to limit it to just one threshold. So if, in this example, if T2 is, if we're in a low T2 regime, the effect of fertilizer F on yield would be beta 1,1. A high T2 regime would be beta 1, 2. And then what we've started to do with some of the Malawi work and the latter paper in Zambia is combining these two types of regimes. So we've got now in this stylized example 4 different regimes. So the effect of fertilizer can depend on 2 different soil characteristics. And one of the reasons this is nice is because, you know, we've got things going back to what soil data are, where, you know, soil physics is a good indicator of a number of things, but it's correlated but not a determinant, right? So you can have quote unquote good soil physics but bad pH, or you know, high clay content but low pH, right? And so this allows for all of those different possible combinations. Right, conceptually, it helps us begin to allow for that. So in this example, if you're on a low T1, low T2, your effect is going to be captured by beta 1,1, low T1, or you know, high T1, high T2, your effect is going to be captured by beta 1,2 and beta 2,2, right? So there's a number of different parameters now that come into it. So why 2 types of thresholds at all? The most flexible model would treat all threshold variables as type 2, right? So ideally, if we have enough data, type 1 is not necessary and shouldn't be used. But when you are trying to use everything as type 2, you're basically splitting your sample a bunch of times, and each time you split it, you're doubling the number of parameters that you need to estimate. So you're estimating more parameters, and you're doing, you know, each sort of subset of parameters is estimated with fewer and fewer observations. So it's a very degrees of freedom hungry process. So we use type 1 as a way of balancing flexibility with feasibility. It's sort of a, you know, second best solution to allow for, you know, a sort of complex relationship between soil and yield, while acknowledging the fact that we just have data limitations. Just some notes on implementation, and then I'll be wrapped up. How do we go about estimating thresholds? What we have done is what we, you know, some have called a grid search. It's a brute force approach. Basically, you just estimate the model under every possible combination of thresholds and choose the one that best fits the data. If you have both type 1 and type 2, a way to save a lot of time and in a you know, asymptotically valid way would be to estimate these in an iterative search, where, you know, first we estimate the type 1 threshold, and then assuming that type 1 threshold, we estimate a type 2 threshold, and then forgetting our first estimate of the type 1 within each type 2 regime, we re-estimate the type 1 threshold, and so on, and repeat that process until we get convergence, and that saves a little bit of time as compared to just the true brute force would be to estimate literally every possible permutation of thresholds. You can bootstrap standard errors for this based on, this is based on work that Hansen did in '96. That was in a time series setting, but we've kind of brought that over to what we do with the soil analysis. Computing average partial effects for interpretation. This is typically because we build things into the model like quadratic terms or other interactions that make the partial effects observation specific. And so to simplify things for interpretation, we look at average partial effects, and you can again bootstrap the standard errors for average partial effects for inference. And then again, just to bring it back to that paper I was talking about earlier that is coming out in Ag Economics, along with that paper, there are help and do files for 2 programs I've written called T1 Search and T2 Search. You can probably guess what they estimate. T1 Search estimates type 1 thresholds, and T2 Search estimates type 2 thresholds. And since now that's all sort of packaged into commands, it makes it fairly easy to bootstrap standard errors for those thresholds. And along with that paper, there's do files on how to do that, you know, bootstrapping the standard errors as well as estimating the thresholds. So without getting into specifics of any of the results that we have, that I think is what I wanted to talk about today. Just in terms of what we've learned about how to measure soil and how to use it in econometric analysis.
Great.
Thanks.
Thank you,
I don't have
Bill.
a timer. I'm sorry. I don't know if I'm over time, but I'm done. So you can have it back.
You were, but it was interesting, so I didn't cut you off. Anyway, thank you. Let's so in the interest of time, let's go to Hope, and then finally to Takashi, and then we'll open it up for discussion. So Hope.
Sorry, I'm trying to stop my share here.
Okay.
Okay, I will try to start my share at the same time. Just a second.
Okay. Thank you.
Okay, 16. Oh, I cannot. Well,
I'm working on it. Sorry. There we go.
I'm not fast. Okay. What do I want to share? Okay. Oh, wait a second. I need to open this as a PDF. I'm really sorry. View, enter full screen. All right, tell me if that's okay. Yeah, somebody who's not muted.
Looks good.
Yeah. Okay. All right. So I'm gonna back up and talk about some bigger issues. I think Bill has given some really rich context, and I'll return to thinking about some of those measurement issues that he and Leah have raised in the context of a specific study. So the first thing that I want to do is just think about this big question, which is, what is soil quality information able to contribute to these big questions in development economics, these big persistent questions? And I think Chris's work here in 2 dimensions is really relevant. So the fellows address that Chris gave yesterday, I think really motivated a special focus on the challenges that and some of the opportunities that Sub-Saharan Africa is going to face in the next 40 to 50 years. And so, thinking about, so I found myself thinking about what the sort of, what is the relevance of soils here? How do we think about soils contributing in particular to the urgency of understanding those challenges, both from a kind of practical applied perspective, like what kinds of policies are relevant, how does soil information help inform that policy design? And then also from the very related kind of empirical questions around designing those policies and evaluating them, but then also kind of understand some of these much deeper kind of generalizable relationships, right? So I found myself thinking about that yesterday. And so I want to raise a couple points that maybe we can talk about. So one is this possibility of measuring these for the first time in the last 10 years, I think because of costs going down and some new technologies, right? The possibility of measuring unobserved heterogeneity across plots and farmers, which opens up some new possibilities for insights and empirical assessments. Understanding the reinforcing relationship between persistent poverty and soil depletion. And Chris and Leah have a really nice discussion of this in a 2015 paper. And then this really important question that I think some work is now starting to brush up against or starting to engage directly of, whether or not there's this endogenous determination of adoption of new technologies, which is really important to understand for these questions of persistent poverty, for these questions of, of resilience and of agricultural growth and inequalities in those growth trajectories, I think. So related to that, obviously, and something that the 2 previous speakers have talked about is, characterizing soil variability and related variation in the returns to nutrient applications. And, we've already talked about this really wonderful paper by Basil and Chris from 2009. John Antle has some earlier work that's quite relevant. And then, last night as I was thinking, I was also thinking about, soils are this place that we can really think about in an immediate way, this feedback relationship, this tied relationship between agriculture and the environment. And that's a very fertile area for this kind of analysis. And I think as we need to think more about that relationship in a concrete way, soils give us a really specific and really urgent place to do some of that work. I think that's one other place to think about. So what I want to do is just give you a concrete way to think through some of these questions by giving you a 3-slide summary of a paper that we currently have in review and that some of you have seen me talk about before. but I think opens up some more specific thinking about some of these things. So in particular, thinking about soil variation, and I want to think about soil information and what use soil information has to farmers and at what scale, both temporal and spatial, that information is useful. So in terms of kind of more clear motivation of that, I think there's 3 ways that soil variation can be important as we're thinking about now having access to characterizing that variation. So one, and the paper I'm going to talk about in the next couple slides was motivated by this question, because I was working with soil scientists for my postdoc, and they were really concerned about the fact that these national, regional blanket fertilizer recommendations may be too crude spatially, and they may not be appropriate for many farmers. And that farmer learning and extension then could also be affected by those, by that kind of hyper-local, even sub-village variation in plots quality. But then there's this other dimension that I've been thinking about recently too, which is I think we need to understand what agronomically meaningful soil variation exists, so that we can think also about inputs and input supply chains and that sort of supply side of ag. Because if we've got a ton of meaningful local variation in soils, that means that the input network has to do more heavy lifting, right? There has to be sort of better advice to farmers about what they need, and there has to be the supply of SA, of some of these micronutrient blends that would be essential for plant growth. And that may be later down the line a little bit, but that's a really important thing to keep our eye on, if that's clear. So a couple of slides on this paper then to make some of this more specific. So this question that I find really interesting and this sort of persistent hypothesis that I've seen circulating in the soil science literature, and then kind of sometimes in kind of older work that engages questions of why the Green Revolution technologies didn't take off in Sub-Saharan Africa to the extent that they did in other regions of the world. This question of whether or not there's more sub-regional soil variation in Sub-Saharan Africa than in other parts of the world, I find that really interesting intellectually, and I'd love to talk about that. But there's this question that motivated this paper, which was, how much variation is there, and how much does it matter on the sort of sub-regional scale, and can we make feasible assessments, right, that are sort of useful to farmers of that variation, and useful in a specific way. So how do farmers actually respond to soil information, and then in combination with liquidity, right? So when we conceived of this research, I was working with a number of soil scientists, and I've worked with them for some years, and I think there is this hope in that community, or in some parts of that community, that information about soil quality and the sort of associated recommendations are going to solve a lot of these problems associated with underinvestment, right? And as the economist on that group, I was frequently the least fun person to talk to about that hypothesis, but we actually were sort of trying to think through whether or not that's true in this paper, right? So what if you give farmers that information in a way that's really designed to be understandable to them, what are the impacts of that on their decision making, on their investment, and then on the yields that we get. So teeny tiny background, we did an RCT in the Morogoro region of Tanzania, 1,000 maize farmers, 47 villages. So one treatment arm got plot testing, so we tested their plot, and then we gave them, through agronomists that worked at Sokoine University, really very clear, very carefully designed, very intelligible recommendations based on the deficiencies that we identified in their plots. One group of farmers just got vouchers that they could redeem for inputs or for cash. And then one group got both recommendations and vouchers. And then we had control farmers in the treatment villages and in control villages. So we could actually think about and measure informational spillovers within villages. So I just want to make a couple points here that I think are relevant to these broader questions. So we found, so this question of large, I think it would be interesting to talk about, but we found what I would characterize as pretty significant variation within regions, as a map of the soil samples that we took. And this is across 47 villages. And you can see here, these are the different limitations that we identified. So we measured 4 major nutrients, so nitrogen, phosphorus, potassium, and sulfur. And these are the different combinations of those limitations that we found. And then we've done some work trying to characterize the sort of within village variation in those nutrients. We also measured pH and we have a carbon measure as well, you know, versus across villages, right? And but there's really significant variation in these classifications for the soils within the villages themselves, okay? So within 120 square miles, these fields exhibit 8 different combinations of nutrient limitations, and you can see the breakdown here. So, you know, this is relevant to what Bill was saying, right? Everybody is basically limited in nitrogen, and 95% of our sample was limited in sulfur, which is really interesting because it's not reflected in the government recommendations for a number of different historical reasons. But then there are different combinations of folks being limited in the other nutrients that we're measuring. So I think the important point for you to know here is that the government recommends NP in the region, and that was only relevant for 5 of our 1,000 farmers, right? So you've got a circumstance in which, in particular, the majority of the farmers, overwhelming majority of the farmers, have plots that are deficient in sulfur, and that's not being recommended by the government recommendations. So that's, I think, interesting. So we have some other study. We have another study. This is actually with Julia and with Chris in central Malawi, and we see similar, you know, distributions of these limitations in central Malawi. And then Amelia Turnstrom has some nice work from Western Kenya, and she sees similar kind of variation. So this is, you know, we're seeing a lot of variation, sub-regional variation within villages. The question that I have is, you know, does that variation matter presently? And, you know, are farmers likely to act on it if you give them that information? And that's why, the reason I'm thinking about that is the following. So the results from our study, right? So we gave some people just vouchers to redeem for inputs. We solved the last mile problem so they could all access the agri input dealer, you know, inputs. And right, some just got the information and some got both. And then at the end of the study, the control farmers got the information about their fields as well. So if you got the vouchers, if you got that, you know, the capital, the access to the inputs financially, and the information, we see that those farmers are more likely to address the nutrient limitations of their field, but they're only addressing the sulfur limitation. So they switch to ammonium sulfate and they add that to the urea that they're buying. And then we see a pretty big, I think we're at like the current estimate based on the production function that we were doing is at about 130% increase in yields. And I can talk about that number, right? Yields are pretty low to begin with. I think they're about 400 kilos per hectare, but we see a pretty big increase relative to the control farmers. The voucher-only farmers, the people that just had a voucher to redeem with the agri-input dealers, they just buy urea fertilizer, which is that's the most commonly used fertilizer in the region. It's being recommended by the government. And then the folks that just got the information are statistically indistinguishable from the control group farmers, both in what they do and what their yields look like, right? So as I said, the farmers who got the information in the vouchers acted to address the sulfur constraint. That's the most spatially prevalent limitation in the sample. It was also the cheapest to address, right? So that input package, adding the ammonium sulfate, was much more affordable than addressing some of the other limitations. So we do see that information helped close, you know, one aspect of the farm-specific nutrient deficiency gaps in the presence of some additional liquidity, right? So, and that there's a big effect on yields in this context of addressing that big deficiency, right? So I want to just, so this is, I just summarized that. I don't want to do that again. So, but I want to end on a couple of challenges and opportunities that I find myself thinking about, both as I engage with this literature more broadly, and then also when I think about our findings and kind of what we're doing next in a couple of projects. There's a few different kind of big headings that I want to pick here, and maybe these are things we can talk about. So the first are issues that Bill and Leah have talked about a little bit, the sort of research methods question. there's cost and logistics of sample collection and analysis. That's fine. I think people are figuring out how to manage those. But I think the more interesting question here, and it's one that the previous speakers have talked about, is this kind of dimensionality problem, and then the stability of these measures over time. Even if you're using the same methods and the same research team. So we have a panel of data on soils from Malawi. I think it's about 700 fields, and we're working with some really good soil scientists, and we're seeing some differences in those measures over time, especially I think in the sulfur measure. And there's a lot of concern being expressed by our soil scientist partners about how we interpret those changes and whether those might just be methodological differences. So that concern that's been raised by the previous speakers is playing out right now for us, and I think that's something that's been a real challenge, because you want to have insight, right, in some of these temporal dimensions in particular. I think the insights from our research and things that I'm thinking about with respect to those findings, soil information alone, I think, is not, and this shouldn't be a surprise to economists working in this context, it's not sufficient to solve problems of farmer underinvestment and low yields, but it could be really important to sort of make sure that what farmers are investing is the most, the sort of most beneficial in terms of input applications. And I think there's important work to be done in terms of thinking about what the right recommendations are, and if there are ways to recalibrate recommendations at a sub-regional level. And I have some, so Julia, who's here, her paper has been referred to before, thinking about farmer understanding of their own soil quality. I think there's more to be done in that space, as Leah talked about. We also have a really fun project that I think is really different and insightful, where we're looking at the degree to which farmers within a village think about a soil test as a public good, and the degree to which they're willing to sort of pool resources to bid on a soil test, and how they think about heterogeneity within their villages in their soil type. So that I think is going to provide some interesting insights about farmer understanding of, within village heterogeneity in soils. Then there's one point I really want to raise that I haven't heard people talk about that much, which is the issue of research peer review in this space. So there's how do we build confidence in this literature? How do we make sure, I think, as the costs of soil testing go down, that we're doing something consistent and coherent, and that we have appropriate, validation and assessment of the soil data that economists are using? I think that's actually a really important area to think about, right? We want to have a coherent and accurate literature, and how do we do that, right? So I'd love to talk about that. And then I raised this point before, right? The soil variation across farmers in the same region means that you have to have input dealers that are even better than they would otherwise be. And then the final question is just about the right spatial level to make recommendations, right? So I wouldn't say, at least in the context where we've done this, that that sub-village variation, I'm really interested in thinking about what that level is spatially and temporally, and to think about what's actually actionable by farmer, who might give them really rich assessments of their micronutrient deficiencies in their soils, but how do we actually help them have the kind of information that they can act on, given the kinds of inputs that are available in the marketplace, and the sorts of resources that they have and the risks that they're willing to take with their investments. And yeah, so I think, we've thought about credit, infrastructure, incentives, storage, aggregation for a long time. And, I'm really excited about the opportunities, but I think not naive about the challenges of how soil variation can map into this really rich existing literature to help us calibrate and what we're offering to farmers, what farmers are able to understand about what might be the most beneficial investment, and then to think about policy and extension design. So thanks.
Great. Well, thank you, Hope. You've raised a lot of really interesting questions, and I'll look forward to talking about some of those points you've raised towards the end in particular. Takashi, thank you for staying up late at night in Japan. I think it must be 11:30 in the evening where you are. So
yes,
we're grateful for you staying up and joining us. Anyway, the floor is Takashi.
Okay, Tom, thank you very much. I love this participating from Japan. You know, I can participate this conference without traveling to US, so that's a very good thing. But bad thing is it's about midnight, so I cannot talk loud. So please turn up your volume if you have difficulty hearing me. So thank you for the three presenters of the papers. So nice, very nice presentation. So many of the points that I wanted to talk about has been already discussed, and thank you for some people mentioning our paper and our project. So I'll just go over what we have done about 18 years ago, and then and updates on something. So the research we worked on is the cold repeat has been mentioned before. So we collected household survey data from sample household from Ethiopia, Uganda, and Kenya. I just show you the map. So these are the samples that we had contacted, and we collected soil samples from these places, including Ethiopia. However, the data from Ethiopia, the test didn't go well. So we had reliable data from Uganda and Kenya. So that was 2004, 2003, 2004 in Kenya, 2003 in Uganda. And recently, my former colleagues have updated with new samples. This is a soil panel data in 2012. I'll mention about that later. But our earlier results were published in a book published in 2011. Talking about the relationship between the soil fertility and the maize production, and also the banana in Uganda. So let me just go to the other publications, but let me skip. So let me go to the measurements, and this has been mentioned. The soil sampling and testing is very challenging. It's costly, and first its logistical challenge is big. So we collected samples from Uganda and Kenya, and samples from Uganda were first tested in Uganda itself with the Ugandan scientists, but we brought samples from Uganda to Kenya to be tested together with Kenyan samples at the same place. That same place is called World Agroforestry Center in Nairobi. So at that center, at that time, it was a new method called the near-infrared reflectance spectroscopy. So this is the NIRS was the method we used. And let's go to the bottom of this note. So NIRS was calibrated using the 20 sample, which were tested with the traditional wet chemical test. So they calculate coefficients from the wet sample to get the coefficients for the NIRS. So this was the method. This will create, this creates problem later on when we talk about panel data, because the first sample, 2003, 2004, were using the wet test at that time. So internally, within the sample, it's internally consistent. But then we collect another sample, my colleagues did, in 2012. So new sample, 20% of new sample using the wet test, and then calculate the coefficient to get the NIRS. So it's, again, internally consistent of the new sample, but how about the consistency over the sample? This becomes a problem later on. But let's now talk about the first survey. So that's the 2003, 2004, and from the different parameters we calculated, obtained from the test, we ended up using mostly soil organic matter. And for the as a measurement proxy for soil organic matter, we used carbon measurement. So that was the one important parameter or indicator we used. We also had the different pH and other indicators, but we had in the regression models and so on. So, but we focused on mostly SOM. Okay, the main study results. So as following the Maranian Barrett paper. We already knew at the time when we were writing paper, so we learned from their paper. And so we are trying to look at the interaction between the soil fertility and chemical fertilizer and its effect on the yield. So so we tried that, and in the OLS, in the cross-section data regression model, we found positive coefficient between soil SOM with maize yield and also banana yield in Uganda. However, when we consider about the endogeneity of the soil fertility, so we used estimated the fixed effect model with the data taking the soil sample as a constant, but we had the household data from 2003, 4, and 2006, 7. So we estimated panel data fixed effect model taking the soil fertility constant by using interaction terms. But in our regression models, mostly the interaction terms were not significant. So we couldn't really significantly identify the positive synergy between the soil fertility and chemical fertilizer use. So that has not been, by our study, could not be confirmed. So at that time, our thinking was that if we had one more sample of soil fertility, then soil fertility becomes the time varying variable, so we can estimate really the impact of soil fertility on the yield. So that's what my colleagues did. So this is the paper, Mugiji and Matsumoto 2020 in land use. This is a sample panel data for the Kenya data. And they also have the data for Uganda, which is they are trying to publish in a different paper. But in the Kenya sample, so the samples were taken from 2004, 2012. Soil analysis was done at the agroforestry center, the same place, and they asked agroforestry scientists to use the same methodology. However, as I said, the samples are internally consistent with the 2012, but then the consistency across samples, that became the issue. So one possible solution is that use the 20% of sample of chemical test and 20% of sample chemical test put together, and then get the same consistent coefficients for NRS, but unfortunately, the earlier sample from 2004 were not available for the 2012, so they couldn't do that. So the analysis was separately. So that's what I understand from talking to my colleague Tomoya was a challenge. But nonetheless, what they found was that they found a decline of carbon carbon percentage from 2004. You can see that the mean is 2.49 in 2004. It's declined to 2003, and it's statistically significant. They used also soil quality index, but this also has declined, and so on. So they have calculated also estimated nitrogen and other factors. One thing they try to correlate with is the population density. So this is trying to capture the linkage between the soil fertility and human behaviors, and in this case, summarized in population density. And then in this part, this Kenya, this central western part of Kenya, population density has increased significantly. And they have, in this paper, they have done multiple tests to see this relationship between population density and then soil fertility. So using fixed effects of this change. So and they found negative correlation. So where that the population density has increased, the soil fertility has declined, and they discussed several mechanisms for between that. So I don't go into details because it's not my paper and I have limited time. But this is a good example of how to use this type of data, and they can and different studies can do more correlating human behavior, farmers' behavior with the soil fertility change. So that would be a very interesting studies. So just a very short presentation. It's still difficult to, I don't see many studies with using reliable soil fertility yet. I learned a lot today, so I've seen many papers in this presentation today. So soil fertility data with behavior is identifying possibly the causality is the challenge, and that's very interesting part. Anyway, so let me stop here and thank you. So
Great, thank you, Takashi. These are great questions to queue up for the discussion, which we should probably go straight into now. So just a couple of ground rules for all of you. If you could use the raise your hand feature there that will sort of put the blue hand next to you. That will help me to call on you and sort of have organized discussion. And if you'd like, feel free to turn on your video when you're talking so that we can see you. Really the floor is open. I think I was going to start off with some kickoff questions, but we only have about 25 minutes left. So let's just go straight into floor discussion. Well, I don't see any hands up at the moment. Let me ask the four presenters if there are any questions that you would like to ask one of the other presenters based on points that they have raised. Bill or Hope, Leah or Takashi?
May I?
Yes, Bill.
Two things. One is in terms of raising your hand, if you don't see where to raise your hand, you have to make sure that the participants panel is open on the right side of your Zoom screen. And you can do that by clicking participants on the bottom of your screen. And then you'll have an option to raise your hand, and chat boxes will be there and everything. The only thing I wanted to say, Tom, was I was reminded by some of the presenters that internal versus external validity of the soil data is a challenge. And sorry, I'll just start my video there. So one of the things that we came across is that validating the internal validity of your soil data is something that's fairly straightforward to accomplish. You can just do blind retests based on your own, using the same method. And so that'll tell you whether or not you're estimating the same value twice for the same sample. And so that's what has been referred to as like the internal validity. But the accuracy of your tests, or the external validity, is something that's much harder to validate. And depending on the lab that you use, there's an accreditation process where they are given samples with known qualities, and the idea is to see how close their results come to those known qualities. But barring that, it's hard to do. So that's one of the reasons that we prefer to estimate threshold effects as opposed to, estimate the threshold parameters as opposed to imposing them, right? So for something like pH, we know that from agronomic literature, they'll frequently say that for maize, 5.5 is a critical pH level, right? And so if you have data on pH, you could theoretically just break your sample into above and below 5.5, right? But there's nothing that guarantees that the way that you measured pH is going to be consistent with the way that pH was measured that came up with that 5.5 number. And so rather than just imposing a threshold that came from some other analysis, that's why we prefer to let the data speak for itself, and we estimate these threshold parameters because again, we know about the internal validity of our data, but we can't say anything about the external validity of our data in a lot of cases. So that was what I wanted to add based on what some of the other presenters said. And that's all. Thanks.
I think that's a problem for like comparability across, like what are the sort of standards of comparability and learning for literature then across? How do you think?
You mean, what is my understanding of how comparable soil results are across?
Yeah, I suppose so. Yeah, I mean, we even ran into this with the soil science team that we work with, using the same methods across different sites, you know, and they're being some kind of art to the way that they're setting like the thresholds on the nutrient limitations. You know, they're kind of like looking at the texture and they're looking at this and kind of figuring out what that threshold is. And yeah, I don't, that just, it feels, I don't know. Yeah, I'm not, there's nothing that articulate that I have to say about it, but it's just sort of like, you know, I keep thinking about how to, you know, what does that mean for coherence? I guess if we just assume that everybody's got internal validity in the studies and that they've been careful, then we're just going to try to be able to say something across the studies that adds up to something bigger.
No, I mean, it's a huge, I think it's a huge problem. And one of the things that I think is problematic about it is that it becomes, to me, in my mind anyway, this sort of red herring where somebody can say like, oh, you know, well, those, you know, your average soil organic carbon is too high. So, you know, your tests are just silly, right? But there could be nothing wrong with the internal validity of the data, and therefore the relationship between, say, high soil carbon and low soil carbon and the effectiveness of fertilizer could be very interesting and important information. But because you have this difficulty in comparing, you know, across samples or across testing methods, you know, this sort of less important issue about, well, in some ways less important issue about whether or not the samples are comparable to each other becomes dominates the conversation, takes all the oxygen out of the room, which is a problem. In terms of how big the problem is, you know, this is sort of the pale of my understanding on the issue, but, you know, Emmanuel Fassard, who I worked with a lot on one of the latter papers that we did in Zambia, has, you know, carved out a part of his career talking about how even the best, most well-respected labs in the world have a hard time comparing their phosphorus results. And so that's, you know, and if, you know, I don't know how to fix that problem, but you know, I think at least it's important to acknowledge the fact that we know that it's an issue, and so we know what we can and can't say, right? And so one of the things we can't say, at least without acknowledging our uncertainty around the issue, is that, you know, based on what I know about soil carbon that came out of my lab, I think your soil carbon that came out of your lab is invalid, right? Like that's not something you should say. And that's not obvious if you haven't worked with soil scientists who can tell you that that's not something you should say. So anyway, that's my thought on the subject.
Yeah. I see a couple of hands up. Let's start with Ellen and then Takashi. Ellen?
Okay, thanks, Tom. Thanks everyone for your presentations. Quick question. For those of us who use AFSIS data, I would just love your thoughts. I know a lot of you guys have collected primary soil quality data in the field. So for those of us kind of interested in the types of time invariant soil characteristics that Bill mentioned, I mean, how terrible of an idea is it to use AFSIS data rather than going out and collecting our own primary soils data?
Great question. Okay, who'd like to tackle that?
I have some thoughts on that, and I'm sure other people do too. So I feel like my journey of thoughts on AFSIS data has really been informed by the different people that I've spoken to. The last one was the most upsetting. I was in Nepal working with somebody who was working with CIMMYT to do this high resolution Nepal soil mapping. And he had worked with the first phase of the AFSIS data creation and then sort of left and hadn't been there for the second phase. And he was super skeptical about the ability of AFSIS data. So as you know, AFSIS data is built on sort of two types of data. They took together all this historical data on soil, so that like from a bunch of different surveys, like different sort of papers over decades, and then they sort of tried to make that more comparable. And then additionally, they went to a bunch of different countries and they did new sampling of soils in target sites. And then they used random forest kriging to interpolate sort of or predict soils across space using both that historical data and the new sample data. And so this guy was really, really skeptical about the usefulness of any of the historical data whatsoever. And I feel like I would have no input on that at all, like if I hadn't worked with the data. So I sort of trust him. he, I know, was more skeptical than some of the people that stayed on. I think he was so skeptical about the usefulness of the data that that was part of the reason that he left. So that was sort of upsetting for me to hear. And then additionally, like the thing that's true about the AFSIS data is that the sampling was not spatially distributed across countries in the way that it would need to be for any given country to have a sort of representative sampling, right? So when you do soil sampling in order to create soil maps, what you need to do is that you sort of take some basic soil sampling in the places that have more variability, you build up so you have even more samples. In the place with less variability, you don't have as many samples necessary because you can get more, you know, bang for your buck over a larger space. And AFSIS just couldn't do that for the whole of Africa, right? Like that's not because they're dumb, like that's just not possible. And so I think for certain types of countries, and I don't even know which ones exactly, but for some countries, there's more information. And for some regions of countries, it might be quite accurate. And then for other regions that weren't sampled or that weren't sampled with enough variability, like it's not that accurate at all. And you can look at the AFSIS data in later versions of the AFSIS data, at least in some versions, you can get bounds. So you can look at sort of the high and the low predicted value, but I've never seen somebody actually use that. So I think the reality is, like when I looked at AFSIS data, compared it to Uganda measured soil data, I saw that over the entire country, it was fairly correlated, right? You know, high carbon regions versus low carbon regions were fairly correlated. I'm sure that's also true in many other countries. I would expect all, but within the smaller you go, like the less and less accurate it gets. So for sure, you don't want to be putting in like village level fixed effects, or obviously then it becomes meaningless because the grids are so small. But even sort of a smaller type of fixed effect, as you put in geographic fixed effects, the variation you're using is probably less and less meaningful. And I think it also bears consideration that the identifying variation that you're using may be identifying, you may be identifying most on certain areas and less on other areas, because in certain areas the map is just better at reflecting the type of variation that you're trying to get at, and in other areas it's not as good. And an intelligent use would probably be to go back and use those bounds and really think about where are the places that you have confidence and where you don't. But I've never seen somebody do that. And even if so, like, are those bounds really very good? I'm not entirely sure. So I think it is useful over a large space, but I'm very skeptical about using it in small spaces. And I think that the confidence intervals around those estimates, we should be using them much more than we are.
Right. Okay, thank you, Leah. Before we move, Takashi, I don't know whether your question is on the same topic or a different one. Sorry, you're muted, Takashi.
No, different.
Different one. Okay, then
Slightly different.
let me ask Julia then. Julia, is yours question on the same topic?
Oh, it's a different topic, but I'd like to second Leah about the AFSIS data. And we did this comparison in the World Development paper that both Leah and Hope referenced in their presentations. Thank you, guys. I think it really depends on your research question, Ellen. If you're looking at country kind of like at the averages and you want to use the soil data as a control for like some sort of a proxy for agricultural productivity of different areas, I would definitely go ahead and use the AFSIS data. But if your question is, you know, some of like Bill's work, carefully thinking about the thresholds, returns to fertilizer dependent on the soil fertility at micro level, I would definitely be very skeptical. And I love Leah's idea of thinking how to creatively use the bounds in the data. I agree, I haven't seen anybody do that either. Thank you.
Yeah, it seems like things that are like geologically determined, right? So versus kind of determined by management seems appropriate. I was at Columbia when they were doing that, and I remember discussions of the sampling process and all the kriging. And I mean, they were working so hard and so conscientiously, but I think there's just a limit based on the methods that they had at their availability. And so, yeah, so I would, as I said, I think the geological stuff seems the right way to understand that. But I think there is a temptation for people to use it at a much finer scale than it's appropriate. I wish they gave more guidance about that.
Great. Thanks, Julia and Hope. Okay, let's go to Takashi.
Yes. So I have a question. Maybe Bill may be able to answer this question. what's the most recent reliable low-cost method of measuring soil fertility? Do we still rely on lab tests, or is there any equipment, new machines that we can bring it to the field and just measure the soil fertility right away?
Yeah, I'm not sure how qualified I am to answer, but I can tell you what we use. So part of the answer depends on what the problem is, right? Like what are you expecting to find in the soil, right? So parts of Zambia are highly acidic, and that's the biggest thing I think that, and it also, I mean, so it also depends on the political context, right? So parts of Zambia are highly acidic, and very little attention in the extension effort is given to teaching or talking to farmers about soil acidity. And so in that case, the best way I think to investigate soil fertility would be to measure pH. And I think the best way to do that in a way that has a lot of verifiable internal validity is to bring soils to a central lab where you know that the buffers being used are the same, and you know it's water-based method as opposed to calcium chloride method and so on. For soil physics, I think is, if you want like an inexpensive way to get a good general categorization, having people that are trained to do field hand-based soil physics. I mean, it's a method that's been around for a long time, but it's very reliable in terms of categorizing soils in terms of the relative quantities of silt, clay, and the other one, sand. And that, like I said, when I was talking about how these, the sort of pros and cons of these different things, that might not have as much explanatory power as compared to soil organic matter or some of the more specific things, because it's correlated with all the things that matter. It's not the thing itself that matters. But to train people and to do it in the field at large scale, and it's a characteristic that doesn't change over time. I mean, that's a really scalable way to assess soil quality. And then for soil organic carbon or organic matter, the one thing I would talk about is look into ways of measuring labile versus total carbon. Because I think that labile carbon is, first of all, you're going to get more variation in your data, which is, as an analyst, a good thing. It's something, depending on what your research question is, the fact that this is such a very important yield determinant or soil quality indicator, and it's something that is more likely to respond to the farmer's behavior, it can have benefits there as opposed to looking at total carbon, which is something that's really mostly determined by parent material and time. So that's kind of anyway, my thoughts on the issue.
Yeah. Yes, I see.
Can I add something to that? Has Hope done rapid? I thought Hope had done rapid on the soil testing.
Yeah, we did. We've been using the soil doc kit, which was developed by Ray Weil and Pedro Sanchez. It's now actually, the exciting thing is it's now based out of Florida State, which is where Cheryl and Pedro have moved. And they are now able to put the kits together and ship them out to people. That happened in the last couple months. So we've had really good luck with that. And we even did one thing that this project that I have with Julia, which was pretty cool. We took the kit out with a really young, smart soil scientist, Malawian soil scientist named Justice. We took the kit out and we did some pH measurements in the field, actually, for the first time. It was really, anyway, it was really cool. So, it's not very articulate, but it's exciting to do those in the field. It's exciting to be able to have the results immediately for the farmers, actually. I think it changes this is testable, and it's a hypothesis of the soil doc developers, but they think that it changes the way that farmers kind of may experience and use the information. There's an immediacy. You don't just come with the kit. You don't just come sample and go away and come back 3 months later. So I think that's a really exciting technological development. So, and I'm happy to talk more about that or to connect people with resources if they're interested in it.
Thanks, Hope. There's someone who I saw visually raise their hand, and I'm not sure, you're listed as R. Naring. Would you like to come in? You'll have to unmute your mic though. There we go.
Yeah, can you hear me now?
Yes, we can, thank you.
Oh, very good, just a couple of comments. I work on the productivity team at USDA Economic Research Service. And I'll keep it just a couple of comments. We have websites you could go to look at some of the soil data that we collected over the years. And the very first thing you need to do when you're looking at soils is put a trained agronomist on your team, a well-trained agronomist. Then the next thing you do is find a very good soil survey, either in Northern Europe or in the United States, and connect that to the site that you're interested in. And then you'll get the job done. There are key things like soil texture, pH that you mentioned, and the cation exchange capacity. It's not the topsoil per se, it's the cation exchange capacity and the topology, how these soils were formed in the first place. And again, you do the comps. So we'll do a comp, we'll compare Illinois to Alsace in France, et cetera, and a district in China, et cetera, et cetera. So we have some stuff on our website, look it up. But again, the first thing you need to do always is have a trained agronomist on your team, either to start, otherwise you're wasting your time, I guarantee you. That's it.
Okay, thank you for that intervention. Let's see, I guess there are a few hands that came up in response to that. Takashi, is your hands up from, would you like to come in, and Julia, your hand is up, and Bill. I don't know whether these are from your previous questions or whether you have more to add.
I had a different question, and it's kind of bringing it up on something that Hope mentioned, thinking about building the research community and establishing the practices. I agree that I'm one of the people who've been working on soil in the last 5 years, and many of you on this call, we're missing some people, but it's a pretty small community. And but for us to kind of gain credibility, yes, sorry, for us to get credibility and take it further, like what else can we do to help refine our practices and get our results externally valid, and encourage others to pay careful attention to the importance of soils, and whether it's from just agricultural point of view or health point of view that Leah is researching. I'm also interested in the environmental impact of soil fertility management. So yeah, what are the thoughts here?
I'll say, I am waiting for the day. This is going to sound very negative, but and I think it's because of some of the work I've been doing on fertilizer quality. I'm waiting for the day that there's a very high profile paper. I can't believe it hasn't happened yet, actually, in a very high profile econ journal that makes a huge statement and does stuff with soils. And we all read it and we're like, that's not the way, you know what I mean? And there's some fundamental difference or limitation in the way that they've done the measurements or the interpretation, and then it's kind of out there, right? And I actually do think that would be it's an inconvenience, because then you have to sort of write every paper around that result if it's not right. I don't mean to sound so negative, but I think I just, now that the cost has come down, I see this a little bit in some of the work that's being done by Precision Ag, a little bit, just because I feel like they're giving out, and they're doing a lot of really good work, but I've seen some presentations where they're giving out information about, whether or not a farmer should be liming, for example, and it's not clear where that information is coming from, or that they've done the due diligence to make sure that those recommendations are appropriate. And I've been in sessions where you push on that a little bit and there's a lot of defensiveness. And I think that's a problem. And, you know, I do feel like we have an opportunity and a responsibility to lead here a little bit, because I mean, a number of people in this group have thought, more than myself, have thought really carefully about some of this stuff. And that knowledge maybe could be made into a public good in some way. And maybe it's there and I just haven't found it, because I don't want to think, you know, the initial motivation for my comments, I think some of these measures are really useful and really important. And there's, you know, we want to get it right, I guess. And that's sort of how I think.
Yeah, great points. I'm tempted to go back to the gentleman, Mr. Naring, because the way that I interpreted what you were saying is that we're not doing it right. We're not doing it right. And I think that most of the people who have spoken here have been collaborating with agronomists and crop scientists all along in their work. But I wanted to give you another chance to say what you had to say, because I think Hope's, what I think she's calling for is for us to kind of, you know, for people who've done work in this area to, along with agronomists, to sort of lay out these issues in a way that would prevent this kind of paper from ever happening, and do have kind of a preemptive way, but sort of, you know, helping to kind of lay out what we know. So let me go back to you, if you don't mind, and tell us what you've heard that would make you think that we're maybe not on the right track.
Well, I didn't say that, but I'm saying that you need an agronomist on the team. And again, not to get into a back and forth, and back and forth.
Okay.
What we had to do in putting together our productivity accounts is be able to identify the difference in quality of a county that's near Tampa in Florida, for example, from a county in Illinois, Champaign, for example, or in Stanislaus County in California, or from, as I was mentioning, Alsace in France, et cetera, et cetera. And then what you have to do is have a rigorous, top to bottom, well done historic data set like the ones done in the United States historically and in Europe historically. And some of these folks went over to places like, and I've traveled there in India and Burma and did surveys way back in the 1880s and 1890s, and these data points are still worthwhile. In any case, we would collect up the available data and have the pH, the water quality parameters, the soil depth, the A, B, and C levels, and have them in a data set and develop parameters to drive the land price data collected and have soil quality measures. And I can refer you, this would collect it up to an article I did in the AJE in 2006 on the impact of urbanization on competitiveness. And so look up the data sources there, and then get back to me, and then again back to the agronomist. We would go at NRCS, put the agronomist that they contact on our team. For example, the I'm struggling with it. Sanchez data set put together by Dr. Smith, and you go to that person, you talk to them, and then you know what they were talking about, and you know how to compare soils across states and across the world. You collect their database in their head and what they put on paper.
Okay, thank you for that. If you want to put your email address maybe in the chat box so we could follow up with you.
Could I just give it to you verbally? I'm struggling with a laptop here that they've given us.
Go right ahead.
Richard.Nehring, Nehring, @ USDA.gov.
All right, great. Okay, thanks very
And
much.
we've gone through all these data sets, and
Mhm.
the data sets in the world are in Northern Europe and the US, period.
All right, good.
I have a quick reply, like thought to that. I think Dr. Neri is pointing out an interesting, or there's a related point. So I would say, to back Tom up, we all agronomists, soil agronomists, and anyone else is working with agronomists. But I think the thing that it actually is problematic that the soil tests themselves have been calibrated for soils primarily in Europe and in the US. And like, we had Cornell do our soil analysis, where some of the micronutrient analysis, and we did some of our nutrient analysis.
Did we?
Oh, can you hear me?
It's either me or you, but you.
Probably me. My internet's very bad.
Okay, go ahead. Just repeat.
The only point I'm making is that I think it is true that because the bulk of historical soil data is in Europe and therefore soil tests have been calibrated for those soils, they are not as interpretable and accurate in other soil contexts. And then there becomes like a little bit of an art where you do need, agronomists. And it's not like a binding constraint, but I think it would be great if we had soil tests that were, like they're picking up the availability in a way that is calibrated such that availability in Ugandan soils might be impacted by other types of things than availability of K or of zinc or of boron in like Midwestern soils, right? There just might be different constraints to availability. So for particularly with availability and maybe with some other factors, it is sort of a problem that the body of soils is in other contexts.
Great. Okay. Great. Thank you very much.
I mean, because what I wanted to say, it relates very directly to that.
Okay.
Not only, first of all, I agree with everyone who's. I think Dr. Nering, you're kind of preaching to the converted here in terms of working with agronomists. I concur. We all agree. I think, and we all work with agronomists. But one thing I would add to that, which is relevant to what was just said, is work with local agronomists. Work with people who are familiar with the soils that you're trying to study, and not necessarily somebody from your own university who's never been there, right? Or somebody, either a local agronomist or somebody who's done a lot of work in agronomy in the area that you're studying, because, as we all know, the soils are fundamentally different in a lot of ways from what some of the people that we would work with are trained to look for. That's all I would add to it.
Yeah. I have a question I'd like to roll out to all of you, or whoever's would like to respond to this, and it has to do with the distinction between active carbon and total carbon, and it kind of gets at Ellen's question about what AFSIS is suitable for doing and what's not doing. So, so this active carbon, or labile carbon, that as Pedro Sanchez refers to it, it's a small fraction of the soil's total organic matter, but it's the component that greatly influences key soil functions like nutrient cycling and availability, soil aggregation, things like that. So, and from what agronomists that we've talked to have sort of told us is that it is more responsive. You can get changes in active carbon measures more quickly in response to changes in management. Whereas total carbon is really reflecting more just the underlying parent soils of the area, and it doesn't change. So it's not responsive to changes in management practice. So I guess my question now, and I think this is consistent with what others have said in response to Ellen, that in terms of plot level, soil quality indicators, AFSIS probably is just too blunt to be able to measure, these hyperlocal changes or differences in active carbon. So my question to you is, have any of you seen or been a part of a study that shows any evidence of which farmer management practices like conservation agriculture or, you know, potholing or any kind of management practices that can move the needle on active carbon in, you know, in a period of 2 or 3 or 4 years.
Okay.
Yes, Bill.
One just point of clarification, I wouldn't describe, from what I understand, active carbon as more important than total carbon. It's a more specific measurement than total carbon. But yes, to answer the latter part of your question, work with Africa Rising in Malawi. We have a panel of active carbon measures and combining that with farm management, and we've seen things, for example, that continuous maize production on the same plot for 5 years, for example, has a significantly negative effect on labile carbon, whereas incorporating residues as opposed to burning and removing them from field has a positive effect on labile carbon. So yeah, I mean, in theory, and as far as at least in this sample is concerned, in the evidence, farm management can affect labile carbon. And in the same data set, we find a significant relationship between labile carbon and yields and labile carbon and the effectiveness of the fertilizers that are applied. So I agree. I think it's, you know, I think it's a really important thing to work its way into our literature. And I don't think it's been very present thus far, but not to criticize us too much for ignoring it. I mean, I think the tools to measure labile carbon have advanced significantly in the last 5 years or so. So we're not that far behind the curve.
Right. Hope, Leah, Takashi, Julia, any thoughts of yours on this issue?
So Tom, maybe, let me see. So the active carbon sounds really interesting to study. At that time we studied, there was no distinction of this. So I think what we have used is total carbon. But obviously, just going back to the our economists contribution, I've worked at the International Rice Research Institute. So I've worked with agronomists and soil crop scientists, but what we can bring to the table is the behavior of farmers. So that's not agronomists usually look at and they work in their own boundary and they don't go over usually their boundary. So we go over easily and then try to link it with the farmer behavior with the soil fertility. We at today's presentation, where we are right now is measuring soil fertility and just going beyond a little bit. But in the future, if we go beyond, I think we economists can bring more on the table. So so in that sense, that active carbon sounds really interesting, and I'm interested to see future studies on this. Thank you.
Great, thank you. Thanks, Takashi.
And I, sorry, just to add on to that, Tom, one of the things I forgot to mention was that, you know, we talk about labile carbon or active carbon. Those terms aren't interchangeable as far as I'm concerned, as far as I understand. But the way that we measure labile carbon is something that is also important. And this gets back to some of the cross sample validity questions that we've been talking about. Working with Africa Rising, we focus on permanganate oxidizable carbon, POXC, right? But that's not the only way to measure labile carbon. It is, however, again, as I understand it, working with agronomists, thankfully, who have sort of pioneered this, is that it is the best, most standardized, least expensive way to measure labile carbon. But there are other ways. So it's not just what you're measuring, it's how you're measuring it. And so even for labile carbon, I think that's something important to keep in mind. And you know, for reasons I described, my vote is for POXC, but that's because SigSnap convinced me that it was the right thing to look at. Thanks.
Okay, I think we're running toward the end here, but I'd like to give anyone who has any comments that they'd still like to pull out a last chance to do that. I don't see any hands raised except for Takashi's, which I think is probably from before. Okay, Leah, do you have? Yeah, please.
To me personally, I would just say that the thing that I maybe hadn't thought about the most, but I really agree with, is Hope's comment about there being sort of like an onus at this point as soil fertility measures are becoming more and more common, to think about sort of how do we create like a collective framework for validity in a general sense. And of course you could argue about the exact types of validity, but I think even with respect to things like, you know, in one country you might find that certain types of nutrients don't seem to be affecting productivity, and in other countries you do. And like, does that mean that it's not important in that country, or is it too low, or is it like it's too low to be important, it's too high to be important? Does that depend on the actual levels or the soil types that were used in one country versus another? Like, I definitely think that it becomes very difficult to compare results across papers as is. And I think like to an outsider who doesn't have all of the knowledge that we have, it might just look kind of sketchy, you know, like why are all these papers so totally non-comparable? And so, oh no, can you not hear me?
No, it's, so I was just agreeing with you.
Okay.
I'm actually thinking in particular of, you know, if you were to look at the empirical evidence of Malawi, I think everybody here is working on Malawi in some way. And my guess is that our estimates of response rates are very different. And, you know, maize response to nitrogen, for example. And this is something that's really, you know, bothered me, you know, just because I think we're giving such mixed signals to the rest of the profession about this. And, you know, another element of this that bothers me is just, you know, a failure to really get at the underlying reasons for these variations. So we all know that the trials should, you know, get much higher maize response to nitrogen than what farmers are getting on their own plots. Okay, there's good reasons for why that should be. But the differences are just so large. And, you know, even it seems in small samples that we have in Malawi, crop response to fertilizer just seems to be very different. So soil could have a lot to do with that, of course. And rainfall could have, just the year in which the data was collected could have a lot to do with that too. But I would be very happy to explore kind of how to, yeah, as you said, kind of collectively put our heads together on these kind of issues. And Malawi would actually be a pretty good case to do that with, given all of the various work that's been done on the, you know, in that country. Yeah.
Could I do one more comment?
Richard, please. Yeah, I saw your hand up.
I've been to 40 countries. The basic issue is certain places have been dealt a good hand. Places like Upper Bangladesh, places like Punjab, places like what do they call it, the Parana in Argentina, Illinois, Iowa. Dealt good hands in terms of the soil morphology. There's a book by Thomas way back in Iowa State. I encourage all of you to look it up. Looks at the soil development over time. That's a basic key thing to keep in mind, and how much you can do in a particular place. That's my comment.
Great, thank you. Okay. Thank you, Richard. Okay. Any of the presenters would you like to have any last words before we close? All right, doesn't look like it. Okay, well.
I would say for everybody, like, what's the thing that you want to work on next, or sort of where are you going with this work? What's currently kind of occupying you or interesting to you? Yeah.
Good question. Yeah.
I don't know, Leah. Yeah, Bill.
So one of the things we've been trying to dig into a little bit more is not just not just looking at the sort of dichotomous relationship between soil quality and fertilizer response rates, but how much do other things play into those interactions, like farm management, timing, weeding, right, is a huge thing that we're finding, particularly in some of the fields we're looking at in Malawi. And so I feel like we, as the group of people who are looking at the, combining behavioral data and lab assessed or lab quality data on soil, are really only starting to scratch the surface of the complexities of the relationship between how nutrients go from anywhere else to plants and food that we eat, right? And like saying, low carbon soils, looking at the relationship between low carbon soils and fertilizers, seems to us, compared to what we were looking at in the even early aughts, right? Seems like a very, wow, we're really getting into some of the complexities of this relationship. But I mean, it's a massively blunt tool, a model that looks at soil as high carbon or low carbon, right?
Yeah.
And so, but at the same time, we need to, I think our challenge is that we're looking at behavioral data, which is by its definition very noisy. And so in order to suss out the relationships between behavior and chemistry, biology, physics, and food, we're going to need a boatload of data or much better data, right? So one of the things I think about is what's the balance between the quantity of data that we get and the quality of data that we get. And I think that there's something to be said for less and better data, right? And so anyway, those are the things that I think about. I don't really have any solutions or pathways forward from there, but those are the things that I've been thinking about. But I'm very curious to hear what you guys are thinking about. And I like the idea of, I think this was sort of hinted at, but I would like for this, sort of community of people that we've started here, where, people who are looking at combining behavioral and soil data in developing country settings, continue to function as at least an informal group, right? And talking about how we're going to build the quality of our work and ensure the quality of our work and avoid that paper that we all kind of shake our heads at. I would like to ask, if I may, and also encourage others to, even before we get to peer review, we don't necessarily have to wait that long to start sharing results with each other. Maybe it's going on a lot more than I realize anyway, and start, kind of getting feedback and realizing who the folks are that we would like to compare our work to.
Yeah.
So that's my thought.
Takashi?
May I just get everyone's attention to the next step? So from soil to the crop. So there are some crops which are good at soaking the micronutrients from the soil into the grain. So one crop, rice crop, that I worked when I was worked on International Rice Research Institute is zinc enhanced rice. So zinc enhanced rice, it is very good at taking zinc from the soil and bring it into the grain. And there are many nutrient enhanced grains which were developed by scientists recently. And so that, I think, will be my research topic at the time of when I was working at IRI. So maybe in Africa, maybe such crops are available. So that could be a next interesting topic.
Yeah, thank you, Takashi. Leah, you were working on that topic. In fact, you were going to possibly present something about that today when I asked you to do things more conceptual. But anyway, I think I might have cut you off a few minutes ago, and I'm sorry if there were some other points that you wanted to kind of carry on with on that. No? Okay. All right. So what are you working on? What's your next issues?
I would say sort of a tiny bit building on what Bill said, like the thing that I think about a lot, and what Takashi said actually is micronutrient deficiencies in soils. And then I think it stems, to me, it relates to so many things, because I think I have I feel fairly confident that micronutrient deficiencies in Africa, and definitely it is true in South Asia, particularly zinc and boron, but also some others, sulfur, are really limiting yields in a way that we don't recognize fully. And so I think zinc deficiency is important for yields, and there's some pretty interesting data from 1 Acre Fund that shows that there's sort of really high returns to nutrient enriched fertilizer. And then I also think that zinc deficiency is limiting, you know, the nutrient concentration of crops in particular contexts. That's a really bad situation. So South Asia with really zinc deficient soils, I think that's definitely happening. Though I think the selenium deficiency in the soils that we see in Malawi, which does transmit to the maize for sure, and has been well shown that by crop scientists, that's probably also happening in the Sahel and some other areas where cardiomyopathy is really common and a main outcome of selenium deficiency. So I think that's important. And I think that then brings it back to this question that Hope raised of sort of the supply chains, because I think the frustrating thing to work in that space is like, okay, so we've recognized this is a problem for yields or for human health, but like, what can you do about it if you don't have enough, if you don't have nutrient enriched fertilizers that are being sold in a local context? And I think then for me, that's brought me back to really thinking more about the importance of organic fertilizers and manure and crop residue and timing that potentially increases the availability of nutrients in the soils and other types of things that farmers can do, which has then brought me to think about like, you know, what can we do to help farmers invest in their soils in terms of organic matter, which is like entirely different set of problems than the inorganic fertilizer constraints. Or maybe overlapping, but different. So I feel like the micronutrients being a constraint in soils is really like, it touches everything that I think about with respect to soils. But I do think it's going to be increasingly recognized as very important in the coming years.
Yeah, very interesting, Leah. Thank you. Okay, and Hope, did you answer your own question yet?
I know, but I can be really brief, just because there's 2 points I want to raise, and one, maybe you can help me with, Tom, which is, you know, we found, I'm really thinking a lot about, it's like the most practical application of my research that I've ever encountered, and I'm frustrated that we're not doing more with it, right? We find this huge, broad limitation in sulfur in that paper, and we find that when farmers address it, we see a huge yield increase, you know, relative to where they start. And so that feels pretty urgent to me, that, and you know, we're still working in that area on fertilizer quality and stuff, and so I've been wondering, like, how do you get like a funder, how do you get a government to attend to that, to think about the way that, because, you know, I presented that work at the World Bank and people were like, oh wow, maybe we should do some recalibration of the recommendation before we do this massive voucher program. I don't remember where it was, in someone in Southern Africa. So it's the first time in my work I've really had a result where I'm like, this could actually, maybe this is something people should be thinking about pretty carefully. Maybe it's sulfur, or maybe it's something else. So I don't know, that's just something that that's a new experience for me, and I don't know what to do about it. Yeah, so anyway, that's just one. And then the work that I have with Julia that's coming up is really interesting, because it's kind of, we're seeing that in these, we basically gave farmers an opportunity to bid on a soil test that would be determined in the village in a number of different ways. And we see that farmers are, and that's just the information. And we see that very poor farmers are willing to contribute towards that soil test. So that's really interesting to me, because it suggests that they see value in that information. And yet that stands in contrast to the result that we have in Tanzania, where people, once they have just the information, don't do anything with it, you know? So I'm thinking a lot also about how farmers value that information and the circumstances under which they find it useful. So that's important. Yeah.
Okay, great. So following up on your first issue about sulfur, that was Tanzania, right? In
Tanzania, yeah.
Yeah. Was it local? Was it, did you say Morogoro, or where was that?
Morogoro. Yeah, it's like 98% of the plots. Mm-hmm.
Okay. Very interesting. I'll give some thought to that.
Yeah.
So I'll follow up. Yeah.
Yeah. I'd love to talk to you about it sometime.
Okay. Thank you.
Yeah.
Okay, good. Maybe we should bring this to a close. We've been going, we should let Takashi go to sleep. Takashi, once again, thank you so much for staying up for this. I realize it's probably tomorrow morning. It's probably Thursday morning for you. So anyway,
Thank you.
And for all the rest of you, Bill and Leah and Hope, and all of the rest of you who have chimed in, I think this was a very nice discussion, and really appreciate all of your really interesting insights. It's really well done.
Organizing, Tom. It was fun. Really organizing.
It was a pleasure. Let's stay in touch. I think that this has been really interesting to kind of compare notes with everyone. So yeah, it'll be a pleasure to, at least as Bill was, informally to kind of keep in touch on these things, and maybe can see what potential there is to put our heads together at some point.
Mm-hmm. Thanks so
Okay.
much, everybody.
All the best to you. Okay, thank you.
Bye. See you.
Thanks, everyone.
Bye.